Brightstorm has thousands of high-quality videos covering all major subjects. Please check out more at www.brightstorm.com.
Basic transformations, if you can wrap your head around the rules of when to move side to side and up and down, can be a huge shortcut, a huge time saver when you're asked to graph fancy polynomials. Look at this last one on the page. Look at this guy we're going to be graphing. Y equals negative x plus 2 cubed plus 3. That's a pretty scary looking polynomial, but we're going to graph it in about 10 seconds. Before we get to that one though, I want to go through all the different transformations possible before we put them all together in the last problem. Okay, so first we're going to be looking at the parent function of y equals x to the third power. That's y equals x cubed. It goes through these key points of 0, 0 for the origin, -1, -1, and +1, +1. And then if you have a negative in front of that, y equals negative x cubed, it's going to go reflected across the x-axis. So here it comes like this. It snakes down like that. Again, you're going over 1 up. Let's look at what happens if I have x cubed plus 2. That just takes that whole parent graph of y equals x cubed, the one above it, and it moves it up 2. So now those points, those key features, are also shifted up 2. There we go. Same thing with reflecting it. I would have now that this graph up here, but everything shifted up 2. So I'm still going to be going over 1, up 1, and over 1, down 1 to get my my other points. There we go. Not so bad. Let's try a horizontal shift, x plus 1 cubed. Now the plus 1 is so tricky because when it's inside parentheses, you go in the opposite direction. Like when we see plus 1, we think, oh, move to the right. Except for just to make it confusing, if it's inside parentheses, you do the opposite shift. So x plus 1 is going to be moved left 1. It's still, just like that original parent, I'm going to have these other points that are over 1, down 1, over 1, up 1, like my original x cubed function. There we go. And what if I have a negative out front? Same idea. It's shifted over 1 and then reflected across the x-axis. Okay, now we're going to do horizontal and vertical shifts all put together. I know, it's kind of a big deal. That plus 2 is going to be left 2. That plus 3 is up 3. So here's my central point that used to be in the origin. From there, I'm going to go down 1, over 1, up 1, and then draw my snake curve for the cubic. Same idea with negative parentheses x plus 2 cubed plus 3. My central point that used to be at the origin now is going to be at -2, 3. And then my other points, over 1, up 1, over 1, down 1. Draw that snaking cube. Alright, so these are just really basic graphs. These are the general gist, the general idea of how the transformations work. These transformations, of course, work for all different types of functions, not just cubics. They work for square roots, they work for lines, they work for parabolas. So these transformations are something that if you haven't seen them yet, you're going to be seeing a lot in your future. They're just a big time shortcut for graphing polynomials.
By 2. I can't do this with you two laughing back there.
Work it. Work it.
So if we had, no, that's not right, 3 coplanar points.
So have you ever gotten off an airplane?
That should be less than. Yeah. Dang.
Is it like 500 degrees in here or what?
All right, so when you're in chemistry class, you're going to be doing a lot of work. You're going to be starting over.
So as an example, we could consider like you've got a chain hanging from two figs. Yeah.